All right. Hi, everyone. First, I would like to say thank you so much for the opportunity to present at the Nortex workshop. So, thank you to the Nortex team. My name is Prabhash Ragber. I am originally from Trinidad and Tobago, so not too far from South America. We're in the Caribbean. Right now, I'm in the US. I'm a PhD student at the Department of Mechanical and Aerospace Engineering at the University of California, Davis. And today I'll be giving a short presentation on our research project and how we have incorporated the Spresense microcontroller from Sony into our project. So a lot of what you would be seeing would have been worked on by my colleagues as well. So I'm presenting on behalf of the entire research team. I'm relatively new to embedded systems and coding and all of this. So I've mainly been focusing on the drone side of things, but I'm now starting to get more into embedded systems. So it's really nice to be a part of this workshop. I've been learning a lot from all of the other presentations. So the title of my talk will be Wildfire Air Toxics Data Collection via UAV equipped with Spresense, where UAV means unmanned aerial vehicle, or commonly known as drones. Brief overview. I will introduce our university and research team. I will then introduce our project. Let me just get my laser pointer 1 second. Right. Then I will talk about the Spresense and how we have included it, incorporated it into our project. I will show some results from some of our experiments. We'll talk about a model that we're developing for smoke propagation, and I will conclude with some of our future research plans. We have quite a few different things that we will now be getting into, and this will heavily involve embedded systems, Spresense, and Nortex. So just a brief introduction to University of California, Davis, or UC Davis. We're located in Northern California. We're ranked 5th nationally among public universities, and we've been collaborating with Sony for over 2 years as part of the Sensing Solution University program. So just a week or two ago, we had our annual meeting with Sony, and we're looking forward to our 3rd year of collaboration, where we'll be getting into a whole new area of research, and I would explain what this is later on. Our research team, so the 2 principal investigators of the project, my advisor, Professor Jowdan Kong, an associate professor at the Department of Mechanical and Aerospace Engineering. Also a principal investigator, Dr. Ajit Kadawila, research scientist at the Air Quality Research Center at UC Davis. This is me. And we also have 2 undergraduate students who were a big part of what you would be seeing in the presentation. They recently graduated, but they contributed to a lot of the work that was done here. So to summarize what my research project is about, basically what we're planning to do, we are going to utilize multiple UAVs or multiple drones for wildfire monitoring. So far, we have been focusing on monitoring the air pollution caused by wildfires. But in this upcoming year, we will be working on a whole new area, which is on wildfire detection, early detection of wildfires using drones. So why is this project so important? The motivation behind it? Well, we all know that wildfires are one of the most significant natural hazards that threaten the US, California in particular, and of course other parts of the world. On average, every year, there are over 62,000 wildfire incidents in the US, and a lot of this happens in California, where we are. Of course, timely response and management of wildfires would depend critically on how early these ignitions can be identified and confirmed. A lot of these wildfire incidents are small wildfires, and if they can be detected early, I apologize for any background noise. So if these wildfires can be detected early, when they're at a smaller size, it will lead to a greater probability of containment and, of course, the prevention of loss of life and property. So we see it as an urgent need to develop an economical and easily scalable solution for early wildfire detection. Currently, for wildfire detection, tower-based surveillance is utilized. This uses optical and infrared cameras, but expanding these networks is very costly. Current fire detection methods rely heavily on people, and current AI-powered approaches have very limited coverage. So our proposed method is to utilize a UAV swarm that is equipped with appropriate sensors, a smoke propagation model that I will describe later, a model-based controller, and onboard edge computing capabilities that can assist with early wildfire detection. We believe that this solution is economical and easily scalable because we can always increase the number of drones that are in a swarm of drones. To summarize the aims of our project, so the first aim has to do with the actual hardware, building a swarm of UAVs that are capable of detecting wildfires. This will include the necessary sensors, microcontrollers, and computing abilities, sensing and computing capabilities. The second one has to do with a smoke propagation model that this model that we've been working on can predict the spatial and temporal propagation of wildfire smoke, wildfire plumes. So how wildfire smoke propagates in space and in time. And this model is what we will be using to help us with prediction and detection of wildfires by tracing the chemical based on concentration gradients. We can lead us to the source of the fire. So that's a general idea. This model, we're aiming for it to be very data efficient. We should be able to use it for control, and we should be able to compute it on board the drone. So edge computing is very important to us. So you can already sort of get an idea of how the Spresense will be a big part of this. The third goal has to do with the autonomy. So we plan to use a model-based control strategy that will utilize the model from the second aim, that will enable the UAVs to autonomously detect the wildfire by tracing chemicals. And we also later on plan to include cameras as well to help with detection. So what have we done so far? So up until now, we have developed the UAV platform. That's what you see up here. It has already been flight tested. And then we have developed two systems for detecting chemicals. The first one on the left here is an air quality sensor package. And so this has different sensors. I'll get into it in a little bit, different sensors for detecting different chemicals. And the brain behind this entire system is the Spresense. We also utilize the Spresense on this system here on the right, which is an air sampler. I will get into the details of how these work. But these are the two systems that we have on board the UAV for detecting chemicals. Recently, we built the second version. So once we finalized the design for the first drone, in order to expand it into a swarm, because we need to use multiple drones, we duplicated this. So we have the second one ready, and we're currently working on our third one. And each of these drones have two independent systems for detecting chemicals, each of which use their independent Spresense microcontrollers. Recently, we've been, last year, actually, we collected chemical data near controlled fires conducted by CAL-FIRE. CAL-FIRE is the fire protection services here in California. They conduct these prescribed these prescribed burns in preparation for wildfire season, and they allowed us to work with them during these prescribed burns so that we can conduct our research and test out our system, collect chemical data by flying the drones near the smoke that was emitted during these fires. Using the data that we collected here, we started working out on a smoke propagation model, and you'll see more about this later on in the presentation. So this is just some more details on each of the systems. So the UAV platform, this is the model of the frame, Tyrant X8 octocopter, has 8 rotors. It weighs about 2.7 kilograms, has a flight time of around 25 minutes, and a payload capacity of around 9 kilograms. The air quality sensor package, this is the front of the sensor package. I'll show you the back just now, which is where the Spresense is mounted. We have 6 different sensors for detecting different chemicals. So this one is for particulate matter, this one is for carbon dioxide, this one is for volatile organic compounds or VOCs, formaldehydes, different gases such as carbon monoxide, and this one measures temperature, humidity, and pressure. All of these sensors are mounted on this printed circuit board, this PCB. At the back of the PCB is where the microcontroller is mounted. This is the extension board, and of course the main board will be attached to it at the back, so in between the PCB and the extension board. And we left the camera below so that the sensor package, when it's mounted below the drone, will allow the camera to be facing downwards. The air sampler that we developed, so how this works is we have these tubes called sorbent tubes. They trap air samples. They trap air particles that in air samples that we collect during the flight. And everything else you see facilitates the proper air sampling. So we have this vacuum pump. We have these different solenoid valves that controls the flow to each of these tubes. We collect multiple samples per flight. Right now we have 4, so 4 samples per flight. And the entire operation is controlled by another Spresense. We decided to keep both systems independent of each other, but it is also possible for us to just use one Spresense later on to control both operations. But for now, we decided to keep it independent. Again, yeah, each system has its own Spresense. This slide shows not only what features of the Spresense we have used already, but some of them are what we plan to use. So I just listed some of the main, some of the features of the Spresense and how we have applied them. So of course, the 6-core processor is very good for edge computing, and like I mentioned before, edge computing will be very important for us when we get into detection, because we will need our model to be computed on board the UAV during flight in real time. The GNSS capabilities is very useful to us. It allows us to sync the chemical data with GPS data, and I will show you some of these results in the next few slides. So we can see exactly how these chemicals are distributed in space by syncing it with the GPS data in 3 dimensions. The storage is very useful for storing our data, and when we get more into detection, we will be implementing not just the original camera, but the HDR camera as well for monitoring during low light conditions. Right now, one thing that I'm working on is how to wirelessly transmit the chemical data on board the drone that is detected from the systems on board the drone to our computer on the ground, so that we can monitor the air pollution in real time. And we're working on applying the LTE Spresense board to help achieve this. So recently we've been discussing this with Sony. We've been working with Amagan Ibrahimi, and she's been guiding us to setting up the LTE board and for us to achieve this goal. Here are just some images of our controlled fire experiments with Cal Fire. So we flew the drone through the smoke plumes and also around the smoke plumes to get a picture of what chemicals are contained within this smoke and how they are distributed. So like I mentioned, we synced the GPS data with the chemical data. So this is, I apologize for this noise. It will go away shortly. We have some equipment running nearby and we cannot help it. So this on the left is the 3D GPS data. So this is the flight path of the drone. So the source of the fire would have been here, and as the smoke propagates in this direction, we would have continuously flown around the smoke in order to capture as much data as possible. Then we synced that GPS data with the chemical data in order to produce this spatial plot. So here's the source of the fire, the smoke propagates in this direction, and we can see how the chemicals are distributed. Of course, the chemicals change in both space and time, so that's why we need a model that can predict both in space and time. And that is what we have been working on recently. The smoke propagation model will utilize the data collected by the drones during the controlled burns. It will predict the evolution of the smoke or the air pollution in space and time. And it is important that it's computed on board the UAVs so that later on, when we get into tracking and detection, we can use this model to help trace from lower concentrations to higher concentrations, which will lead us closer to the source of a fire. Here are just some results from our smoke propagation model. These are the actual measured values, and these are predicted values from our model. A lot of it is similar. There are just some small differences in some areas. So it's been a good match so far. So we have a lot of future plans that we are aiming towards over the next year. We have collected data using one UAV, but when we have the full swarm ready, we would actually collect data using the entire swarm. This will allow for better data collection. We will be able to collect at different points in space at the same time, which will help with our model. The next big goal is IoT sensors and UAVs for early wildfire detection and tracking. So we'll be getting into tracking, detection and tracking. This will involve not just the chemical sensors, but also the cameras. And later on, we'll get more into machine learning algorithms. We have to implement the smoke propagation model on the Spresense itself. This will be computed in real time on board the UAV. We will, like I said, we'll be including the HDR camera into our detection framework. And we'll be applying model-based control for optimizing detection and tracking. So that is basically what we have worked on so far. Within the next year, we'll be getting a lot more involved with embedded systems. So there's a lot of opportunity for us to explore different features of Spresense and basically utilize more of Spresense and NUTX. But I personally am relatively new to embedded systems, so this is something I'm now learning a lot more about. So looking forward to learning more throughout the workshop, and over the next year we will be applying a lot more of this to our research. So that is pretty much what I have for now. Would like to thank you so much again for the opportunity to present. And if you have any feedback, any suggestions, or any questions, feel free to ask. Thank you so much.
Thank you, Pravash. Are you hear me?
Yes.
Yes, sorry. I needed to take off my headphones to avoid the microphonia. All right. Do we have any questions here in the room? Do you want to ask him something? So I would like to. Does anybody else? Well, about the feedbacks, your presentation was very directive. We enjoyed it so much. And I would like to ask you, the beginning of your presentation, you presented the team you are working together.
Yes.
You also said about the different applications you are building using different hardware resources and features.
Yes.
So I suppose you are developing applications independently. Maybe some part of the team develops one kind of application, and
Yeah.
other part of the team develops other kind of applications. So I would like to know how Nutanix contributes to this distributed workflow, because usually when we are talking about bare metal systems or other kind of operating systems, it's somehow difficult to develop them independently. So I would like to know if you have faced some difficulties, or if it's more easier to develop these kind of distributed applications, and maybe how do you mock the unfinished interfaces to test these applications independently? I would like to know a little bit more about it.
Okay, sure. So I personally have been focusing more on the drone side of things. My colleagues would have been working on like the embedded systems. I'm now getting more into the embedded systems and learning more about that. Our team works very closely. So the PIs, we work very closely with them. Right now, I'm the other students graduated, so it's really just me that's trying to like learn more and get more involved in the different aspects of the project. But so far, we have not really faced difficulties in terms of different people working on different parts of the project.
All right. Alan has a question. We have another question from the YouTube channel. Go on, Alan.
Hello, Prashad. Really good presentation.
Thank you.
You did it really well. My question is most about the things you are developing. This project is open source in some way. You are putting this in GitHub or something you want to talk about. And for the Swarm as well, the future plans. I think Swarm is a very hot topic and very interesting. It should be nice to have something open source that community can use. Yeah, that's it.
Yeah, we most of what we use is open source, and yeah, we're always happy to share what we have worked on as well. So that's not a problem.
But I was muted. We have a question from the YouTube. What flight controller is used on the platform?
We use the Cube Orange by Ardu Pilot, and we use Mission Planner as the ground control station.
All right. I think we are done with the question. Does anybody else wants to ask something, or should we move on? Well, thank you too much, Pravashi.
Thank you so much.